Hello everyone, I'm MS Shweta from First MSc Microbiology. Today we are going to discuss about the chemical method of sterilization. First, what is sterilization? Sterilization is the process of making surface or medium is free of all living organisms. Sterilization is the process of killing of microorganisms. Sterilization can be defined as the complete removal of all forms of microorganisms, both vegetative and spore forms, present in the surface of the object or fluid. Sterilization was carried out by two methods, physical method and chemical method. In chemical method of sterilization is the process of killing of many microorganisms, but not all microorganisms. Chemicals used for disinfections are called as disinfectants. Chemical method of sterilization can be carried out by three methods such as disruption of cell membrane, modification of proteins, modification of nucleic acids. In disruption of cell membrane, they have three disinfectants to disrupt the cell membrane, such as alcohol, detergents, phenols. In alcohols are widely used to clean the skin before venipuncture. Venipuncture is the collection of blood from your vein. Alcohols act mainly by disorganizing the lipid structure in membrane and also denatures protein. 70% ethanol is often used as an antiseptic to clean the skin. In detergents are surface active agents. Detergents are composed of a long chain, lipid soluble, hydrophobic portion and a polar hydrophilic group, which can be a cation or an anion or a non-ionic group. Detergents interact with the lipid in the cell membrane through their hydrophobic chain and with the surrounding water through their polar group and thus disrupt the membrane. An example for cationic detergents are benzyl alkonium chloride. In phenols, phenol was the first disinfectant used in the operating room by Lister in the 1860s, but it is rarely used as a disinfectant today because it is too caustic. Hexachlorophene, which is a biphenol with 6 chlorine atoms. It is used in the germicidal soaps but concern over possible neurotoxicity has limited its use. Phenols not only damage membranes but also denature protein. Second, modification of protein. Modification of proteins have seven disinfectants such as chlorine, iodine, heavy metals, hydrogen peroxide, aldehyde, ethylene oxide, and acids. First, chlorine. Chlorine used as a disinfectant to purify the water supply and to treat swimming pools. Chlorine also the active component of hypochlorite which is used as a disinfectant in the home and in hospitals. Chlorine is a powerful oxidizing agent that kills by cross-linking essential sulfhydryl groups in enzymes to form the inactive disulfide. Second one, iodine. Iodine is the most effective skin antiseptic used in medical practice. Iodine can be supplied in two forms, tincture of iodine and iodospores. Tincture of iodine is used to prepare the skin prior to blood culture. Iodospores are complexes of iodine with detergents that are frequently used to prepare the skin prior to surgery because they are less irritating than tincture of iodine. Third one, heavy metals. Heavy metals are mercury and silver, widely used in medicine because they have the greatest antibacterial activity. They act by binding to sulfhydryl groups, thereby blocking enzymatic activity. Some of the heavy metals are silver nitrate, silver sulfadizine. Silver nitrate drops are useful in preventing gonococcal infection. Silver sulfadizine is used to prevent infection of bone wounds. Fourth one, hydrogen peroxide. Hydrogen peroxide is used as an antiseptic to clean wounds and to disinfect contact lens. Hydrogen peroxide has effectiveness because it's limited by the organism's ability to produce catalase and enzymes that degrades hydrogen peroxide because the bubbles produced when peroxide is used on wounds are formed by oxygen arising from the breakdown of hydrogen peroxide by tissue catalase. Hydrogen peroxide is an oxidizing agent that attacks sulfhydryl groups, thereby inhibiting enzymatic activity. Fifth one, aldehyde. Formaldehyde, which is available as a 37% solution in water. Formalin denatures protein and nucleic acids. Both proteins and nucleic acids contain essential chemical groups, which are the main sites of alkalization by the hydroxyl methyl group of formaldehyde. Glutaraldehyde, which has two reactive aldehyde groups, is 10 times more effective than formaldehyde and is less toxic. In hospitals, it is used to sterilize respiratory therapy equipment. Sixth one, ethylene oxide. Ethylene oxide gas is used extensively in hospitals for the sterilization of heat-sensitive materials such as surgical instruments and plastics. It kills by alkylating both proteins and nucleic acids such that the hydroxyl ethyl groups attacks the reactive hydrogen atoms on essential amino and hydroxyl groups. Seventh one, acids. Strong acids and alkalis kill by denaturing protein. Weak acids such as benzoic acid, propionic acid, and citric acids are frequently used as a food preservatives because they are bacteriostatic. The action of these acids is partially a function of the organic moiety. Third method, modification of nucleic acid. A variety of dyes not only stain microorganisms but also inhibit their growth. In this modification of nucleic acids, they use crystal violet and malachite green. First, crystal violet. Crystal violet is used as a skin antiseptic. Its action is based on binding of the positively charged dye molecule to the negatively charged phosphate group of the nucleic acids that inhibit the growth of microorganisms. Second, malachite green. Malachite green. A triphenylamine dicrystal violet is a component of Lowen strain Jensen's medium, which is used to grow Mycobacterium tuberculosis. But malachite green inhibits the growth of unwanted organisms in the sample of sputum during the sixth week of incubation period. Thank you for your listening.